Welcome. Good afternoon. Today's webinar is initiated by our ITCNL community. Well, great to see you again. So many people are here today. We've received very positive feedback on our first webinar, the topic special, so to say, which we held on April 29, so about 2 months ago already. Well, this topic special platform was organized by us to look into and discuss topics that, well, we think affect all of us within the semiconductor business. How do we deal with those developments? What are the challenges? Where are the opportunities for the semicon industry within the Netherlands? That's the things, the kind of things we'd like to discuss. Well, and as mentioned before, we feel responsible to create and facilitate a platform towards all Dutch semiconductor business companies. So thanks again for joining us today. Let's see which new steps towards an open-minded and safe environment where we can all talk about our concerns, experiences, and, well, topics we think about at night during our spare time. But first of all, please let me introduce myself shortly. Tom van der Dussen, project manager within Holland Semiconductor. That's the semiconductor cluster within the larger community ITCNL. In total, we have about 250 members, which are 70 in the semiconductor industry, which we are very happy with. Well, and I'm very happy to work for this great community and be part of the team. Together with my colleagues and, well, all of you, of course, I like to play a valuable role to bond our members between each other, but also towards international markets and our sister organizations like in Germany and France. And we absolutely look across borders. In 2 weeks' time, we will have a new webinar focused on the Taiwan business. Please join if you can. And of course, in case you'd like to learn more about me or know what we are doing, drop me a personal message, give me a call later. And I'm here, I'm available and ready for you to help you, of course. Before we start today, some household messages, so to say, a few practical things. The session will be recorded so that you and others can look back at the information shared. Please mute your microphone and your camera if you wish, so that you're not visible. We use Microsoft Teams, which means you can raise your hand, so to say, if you want to add a question or a remark. And of course, you're all visible, your names, so then we can see who wants to send in a question. You can also use the chat to make a remark or already drop a question for us to answer later. Today's topic special, what's going on? It's all about advanced packaging. As you can see in these pictures, quite some things happened in the past 80 years. First, you had a room full of equipment to make a few simple calculations. Back in the 70s, it was already a single chip doing all the same. And well, nowadays, with advanced packaging, as you can see, there are dozens of combinations on one single chip. Transistors are shrinking, so a lot of data is going through those microchips. But of course, no need to tell all of you. And of course, looking at the program who we have today, as you can see, those are 3 major specialists with a lot of knowledge. So Mr. Erik Bijnen, the first speaker, he's a senior fellow and vice president of R&D at the IMEC research facilities in Belgium. As you may know, IMEC is an R&D hub for nano and digital technologies. So no need to say, they are a perfect contact towards our community. Of course, same goes for Mr. Barry Pate, our second guest of the day, general manager of the CITC in the Netherlands, based in Nijmegen at the Novio Tech campus. They're a non-profit innovation center developing packaging and integration technology for chips to provide solutions to societal challenges. And last but not least, Mr. Oliver Maywald, CEO of Sensio, also based in Nijmegen. They're an independent package design and assembly company, which offer functional packaging solutions for MEMS, integrated sensor systems, with a primarily focus on automotive and industrial applications. So 3 great people who will tell us a lot more today. As mentioned, we have a tight schedule, so I'd like to bring the spotlight towards Eric at first. Hi, Eric. Good afternoon. If you're ready, can you share your screen and tell us more about your ideas and experiences from R&D towards packaging market? You ready? Maybe your microphone is on mute, Eric. I cannot hear you yet.
Okay. Yeah, maybe you can see me now.
Don't see you yet, but I can hear you clearly. Okay, you're visible. Okay. I get that. Sure.
Okay, yeah.
There you go.
Sometimes it's strange. So yes, my name is Eric Ben. I'm responsible at IMEC for the 3D system integration program. And if we talk about this topic of advanced packaging and integration, what people often consider is the fact that CMOS scaling may be at the end. Actually, CMOS scaling still continues, but of course, with increasing complexities. And I think definitely for the high performance type of integration, big issues related to scaling are related to memory, data access, and specialization of chips with respect to data handling versus computing. And then the problem of heat removal, where we actually come to what we call a power wall, where it becomes difficult to cool the chips beyond a certain limit. And of course, solutions to that is going into multi-chip heterogeneous integration, where you have different chips that are coming together to form, that become the system. Okay, so this, I hope it works well now. So you could see a complex system for the future as a system that handles data that come in from outside of a module, for instance, through an optical interface, where optical fibers bring in high-speed signals that translate into electrical signals and then are fed into the electrical part of the system, where one die is actually kind of a data gateway, a management system for data, which brings the data to local storage or to local computing that may be heterogeneous and may have a lot of local memory stored on top of it. So this is what people sometimes refer to the chiplet technology assembly as well. So interconnects between devices then are stressed either in a lateral way, where you have high bandwidth interconnects on a planar substrate. Sometimes this is referred as 2.5D interconnects, where your bandwidth and interconnect density depends on the pitch, the interconnect pitch you can make in your interconnect technology, and the bandwidth of each individual channel. And one of the big changes, you could say, with HBM memories is a move to wide I/O interfaces, where you may have a lower frequency but many more connections to make, and that drives a requirement for fine pitch interconnect technologies. If we go to full 3D stacking, you don't use the perimeter of the die, but the area, so you can actually do much more connections between the die and achieve higher bandwidth, partially because the distance is very short, but also because, of course, the area available at the pitch is much increased. Behind that background, you have this whole trend in so-called chiplet integration, where SOC chips that otherwise would have been a single monolithic integration chip are being broken down in pieces. You see this, for instance, with AMD's latest chipsets and also chipsets from Intel, where you separate out separate functions. And in the chiplet approach, the idea is that you can separately design both blocks, and that you introduce a so-called PHY interface block, an IP circuit that connects or makes the connection between the two chips possible in a kind of standardized way. So company A and company B can independently function to make their chip, and then the standard makes sure that the two chips can talk together. Great, but of course you're limited a bit in what you can do, because this additional circuit will add latency to the system. So it's mainly for the let's say higher layers of the cache system. Also here there is a need to drive bigger buses to get more interconnect density, and also a drive to go to lower pitch interconnect at the chip, because ultimately all these wires are connected with bumps. So the size of that bump array is defined by the number of wires, and that kind of quadratically scales in area with the pitch. So it is important to reduce pitch to save area on the die, which is expensive. In an HVM interface, that phi is the contact area of the bumps is even 6 square millimeters, so that is quite expensive in advanced technologies. So these are factors that are driving pitch scaling, and some of the announcements lately from some companies are driven because of this. A very different approach that we are also at IMEC looking at for 3D integration is actually what we call a 3D SOC view, where you keep the methodology of SOC design, but you partition automatically in the ADA tool itself. This is only possible, of course, if you have access to the EDA and the PDKs of the systems. So you have to co-design them. And by doing so, you can actually create truly co-designed 3D interconnects. And of course, you can gain more. There's no latency in between the levels, and you can get very high performance from a 3D stack. But of course, you need to be able to handle both designs at once. All these types of ideas of 3D integration require, of course, technology, not only the EDA. And in 3D integration, we often talk about true silicon vias and how they scale. This is, let's say, the most known aspect of 3D integration. Current industry kind of standard TSVs would be 5 micron diameter, 50 micron deep, or 10 micron diameter, 100 micron deep for interposers. That gives you about 10 micron pitch capability. But if the bumps are only at 40 micron, that means there is a huge interconnect gap between the two, so we need to overcome that. And that's also where these micro bump interconnects come into the picture. So scaling micro bumps is important for that. So it's possible to go from what is used in industry today at 50 to 30 micron to scale that to 20 micron, and we've shown even going to 7 micron pitch in multi-tier stacking, solder-based micro pitch bumping. So that is one of the directions we see becoming more and more important in the industry. What is also becoming more obvious is that people are interested in bumpless connections. Recent announcement by AMD on using a TSMC technology, so-called SOIC technology, fits in that direction, where you actually have paired die without any bumps that you put on top of each other, and they make magic connections. Work perfectly in PowerPoint, but in practice, of course, you need to have ultra clean surfaces, ultra smooth surfaces to enable this type of connectivity. So a lot of work also with some of the companies in the Netherlands is ongoing on making equipment that can handle this type of stacking. Bringing the cleanliness of fab-like environment to a packaging environment, which is a kind of a big shift in paradigm, because normally in these back-end technologies, you have less restrictions on particles and cleanliness than in a fab environment. But for this particular type of structures, you are actually entering into really a wafer-like environment for processing. This technology is derived from wafer-to-wafer bonding, which is a technology that allows already today to go to the micrometer level. And we've actually went down to pitches like 700 nanometers to do this connectivity. So if I bring that all together, you could say in 3D interconnects, you have a big scala interconnects, you go from the millimeters to the nanometers to transistor level stacking. So interconnect density scaling is like 9 orders of magnitude scale. So one technology will not be able to do all of that. So we try to look at technologies that are more on the package level, like for package-to-package stacking, 2.5D interposer-like technology, going to flip chip, wafer-to-wafer bonding. They all have their own area where they are active. Of course, these technologies are not standing still, they are moving. Each of them have their own roadmap. So this is not a traditional roadmap slide, I call it a landscape slide, because each of these technologies move forward and eats a little bit into the neighboring technology. And as everything in semiconductors, scaling is the only way forward. So if I put it on a time scale axis, you have these technologies now in the vertical axis with respect to their interconnect capabilities. And what we see from our research and from the industry, there is a strong tendency for all these technologies to further scale significantly in the next decade. And of course, the big question will be how to make use of that. Also, not only for the high performance computing paradigms, but also for lower volume sensor applications or other tools where that is an option or not. But to conclude, I would say that in the end, to be successful in this kind of heterogeneous integration, we will need to embrace all these different flavors of the technology to really get the best situation for a specific application. Thank you.
Well, thank you, Eric. Very nice to see. I've made a few notes and I think 2 possible questions, but I'll save them for later. I assume you'll stay available for any questions afterwards.
Yeah, of course.
Okay, very nice. Thank you. Barry, welcome.
Yes.
Are you ready to show us some of your slides and tell us more about your personal or CITC's point of view on the developments? Cool. Thank you.
Let me see if.
Yep.
Yeah, do you see the slides?
Yeah, I can see you.
Okay.
Very
good. Okay. Thank you all for being here today. Today's a very special day for us and also for me because this is the first day of the 3rd year of CITC. So we started 2 years ago, and July 1st is the first day of the 3rd year. I'm going to say a bit about CITC in general, just to give a bit of background. We are an independent R&D center founded, as I said, 2 years ago by, amongst others, Holland Semiconductors, so by the organization that is hosting this one, together with TNO and Delft University, located, as was said by Tom, on Novitec campus here in Nijmegen. And we started with initial customers, the big guys, let's say here on the campus, NXP, Nexperia, Amplion, all the IDMs, device manufacturers. Let me move this a bit. So the reason we started, and I think this is crucial also in the context of this presentation, is that integration and packaging technology is of growing importance. As was said by the previous speaker, Erik, already, advanced packaging and also heterogeneous integration is getting more and more important, also functional-wise. And this was the reason that we set up CITC. There's a need from the industry to co-develop new technology, and this is exactly what we do with our partners. So we basically we transferred this to 3 offers that we can give to our customers. First, and I think most important one, is the access to innovation, where we organize and run innovation programs. I will elaborate a bit on later on different aspects of advanced packaging. The other one is also infrastructure. So we have a lab here that we use, but also our customers can use. And last but not least, we also give access to education, because being a more and more important topic, advanced packaging, it's also crucial that we find the right people that know what advanced packaging is and that will work in the industry now and in the future. So as I said, we are located here on the Novitec campus, and this is not a coincidence. This is because our big customers are here, but it's also because there are a lot of companies here active in the semiconductor value chain. For example, EPR, NTS, and of course, last but not least, Sensio, and we cooperate with all of them. And that's again, I will talk a bit later on this topic, but I think collaboration on the whole value chain is of key importance in advanced packaging. So on the topic of packaging, as was said already by Erik, advanced packaging is getting more and more important, and we see the topic of advanced packaging in all the different aspects of semiconductor industry. So the themes that we are working on are the themes that are shown here on this slide. So one of them is RF chip packaging. So those are the challenges in the very large, very high frequency domain, 100 gigahertz plus. But also on thermal high performance packaging, the high power chips that are very important nowadays in the semiconductor industry. And Xperia is, for example, a customer that we are working together with this on this topic, and also Amprion. Those are the challenges of having thermal aspects that are very difficult when high power and high currents are flowing through high power chips. The other one is digital packaging manufacturing. So one of the things we are working on also with our customers is how to improve and to innovate on the manufacturing itself of packaging. And last but not least is integrated photonics packaging. So more and more solutions are being developed where the combination of light and electronics is being integrated in one chip. And packaging of these modules of these chips is a very challenging part. And also is the cost part of this. This is nowadays almost 80% of the total product cost. But not only does it appear everywhere, it's also involving everyone in the value chain, as I said before. So we started off at CITC with the IDMs, so device and component manufacturers. But we see that inclusion of, for example, material suppliers is key, substrate suppliers, eventually also equipment suppliers that enable us to make, or our customers enable our customers to make the actual products, and eventually also the system integrators. So it's key to have everyone aboard when developing new technologies in this domain. It also requires a lot of different competences, as you can see on this slide. For example, characterization of materials is a very key element, both in the high spectrum domain, the high frequency domain, as the high power domain. Design and simulations, where the combination of thermal aspects, mechanical aspects, and electrical aspects are key. Failure analysis. So what we do here is failure analysis of packages by thermal cycling whilst being in operational mode. The chips that we test, it's of key importance as well. And also eventually the building up of the package, the expertise and the capabilities of assembly and integration. So all these aspects and these competences are key to develop new packages. And these result in very complex solutions. So as you can see here, I show a few examples of things that we're working on. In the top left corner, you see a high power solution where we do die attach on copper lead frames using silver sintering, where the CTA mismatch is of crucial importance. And this is especially of relevance when we see the high power chips going down in cost and going up in volume, that new technologies are needed to increase the volumes and at the same time lower the cost. At the right top, you see an example of RF package design, and in this case, especially the multi-material and multi-layer aspects, as you can see on this picture, are a key challenge. But we use air cavities to work with different dielectric constants and enable them to be in one package using, in this case, the very high frequency domain, or enabling very high frequency domain solutions. In the right bottom, you see an optical and electrical combination in one package, where we use so-called optical waveguides that enable us to have part of an optical die and part of an electrical die being combined in one package. This is a solution that's not yet out there. We are still in design phase of this solution, but this is very important as well. And all these new and advanced solutions also require new technologies. I saw Erik already explaining a bit about two polymer vias. the picture in the right bottom corner is an example of two polymer vias where we are working on together with TU Delft. The other one is so the top right picture is a picture of a test chip that we use in the what we call in situ environment, where we have chips that are operational in an oven chamber that cycles to temperature, and we can see the effect of these temperatures on the functional of the chip, and also see what the effect is on the package. And on the two left pictures, you see examples of distribution layers that are being built using 3D printing, additive manufacturing technologies that we do together with Hols. So these are new technologies that we use in order to develop new package solutions. And last but not least, of course, the advanced tools that are used in order to do all of this. For example, laser interferometers that have a resolution of 1 nanometer. The alignment tools that are shown in the left bottom corner that also have a very, that's an active alignment tool that is very accurate up to a nanometer accuracy. And in the top right corner, you see the oven that we use for this in situ setup, as I just explained. But I think most important, as we see it, is the cooperation. I think one of the key elements of the Dutch ecosystem is that we are very good in cooperation. But of course, it's not limited to the Dutch ecosystem. That's a more and more European cooperation that we are working on. And we are not only cooperating with companies, but also with universities, with public entities in both the direct environment here in Nijmegen, but also in Europe and in Gelderland. And I think, given the geopolitical situation where we're now, it's more and more important that we extend this cooperation. And we also see opportunities for this in, for example, the Groeifonds and in the IPSAI on microelectronics. And I think this is the way to go, not only for us at CITC, but especially for the Dutch and European ecosystem that is working on advanced packaging. So that's why I would like to end my slideshow, Tom.
Well, thanks, Barry. Thank you very much. I really didn't know it is your anniversary for your company, so congratulations.
Thank you.
Yeah, wonderful. Good to see. And yeah, also great to learn more about CITC's background and well, the new technologies that you are working on, and that you support so many partnerships working together. I think it brings us a lot more. Just one quick question. Eric mentioned before about cleaning, that cleaning surfaces is a major issue. Is that one of the topics you are also handling within the CITC?
Not yet, I would say. We do see this in the future. I think the difference between what Eric explained and what I explained is that Eric is more working on wafer level packaging, and we are more working in the, let's say, in the single package level. So the cleanliness is not yet an issue in the topics we're working on. But it's eventually it's going to be, because we see more and more going towards the middle end, where you get closer to the front end, and the cleanliness and accuracy is getting more and more important.
Okay. A future topic. Okay, cool. Thank you, Oliver. I'd like to give the floor to you. Welcome. Great to see you want to join and tell us more about your market experiences. When you're ready, please share your screen and tell us a bit more about what you are doing in the chip production process.
Can you hear me?
Yes.
Can you hear me?
Yeah, and we can see your screen. Thank you. Take it away.
I try to get the presenter slides as well. So let me see. Stand up. And then this one. Okay. Thank you. Good afternoon. And yeah, let's talk about Sensio shortly. We have 3 slides of Sensio, and then I want to go to the advanced packaging. Sensio, we have a bit longer history than the other 2 partners. We are founded 1987 already as the company Eurosem, but then 2011 we have been founded Sensio, and since 2015 we are at the NTC located next to the big semicons here around Amplion, Nexperia, NXP. Short facts and figures about us. At the moment, 47 peoples. IATF certified, this is the automotive certification. And one major achievement from our lines, within this time, we made 400 million assemblies just for the automotive industry. Automotive is for us, is in our heart. So it's the biggest market for us. We still have other packages as well. So industrial, medical, and also aerospace packages. However, the major achievement is really automotive. We develop and manufacture in Nijmegen, but we have also a Far East location on the Philippines. Core business for sure is development and functional and encapsulation solutions for packages. We do this directly for volume manufacturing because Barry is more on the samples, I would say, and we go directly to mass production, which means in several millions normally. Next to this service, we offer wafer processing. It means wafer backgrinding, wafer sewing. We also have a sample line for ceramic, plastic, fast and prototyping samples. We can do small, medium volume, QFN, whatever small, medium means. We can do component supply management. That means we buy the components and then we assemble it completely and make it and sell a complete package back to the customer. That's how we see the value chain. So there are the wafer fabs, the foundries like IMEX, for example, or the Nexperias or TSMC. So they have their wafer fabs. Then there's assembly and test, which is a single packaging device normally. Then the PCB assembly happens and the module assembly, and then it goes up to the application. For sure, the automotive way. And as said, component supplier. Then we have the system supplier, and in the end, we have the OEMs. And the OEMs, they have an application challenge normally. It doesn't matter if it is a harsh environment or it is a miniaturization. So, and then they come to us and we offer them the application solution. This is how we think on the market. And if you look to the advanced packaging type, we are always talking since 1970s already about advanced packaging. So it's just moving the technology far more ahead. And we are now, for sure, at 2020. And for us, the advanced packaging means that it is not a single component, that there are more components, more devices in one package. That's for us, the advanced packaging. So, for example, our high runner at the moment, which is an oil level sensor, there you can see there's a ceramic disc included on the left side. There's an ASIC, the green part is an ASIC inside. Then you have passive components around, you have diodes inside, and all together is encapsulated and used in the car motor oil from -40 to +150 degrees. So this is for us advanced packaging, but also harsh environment packaging, because -40 to +150, normal electronics doesn't work there anymore. But we can package it, let it works like that. The same we do for oil pressure sensors. I did forget, this part is running at the moment and between 9 and 10 millions a year from our lines. This one is an oil pressure sensor, the same way. So there's a pressure cell included. There's an ASIC included. There are passive components included. Everything encapsulated and then used into the car motor oil to measure the oil pressure of the oil pump. For sure, other pressure sensors like this one, so ASIC inside, pressure sensor outside, such kind of things. So, and you still see passive components all around. So we integrate much more than just one component. This is for us the advanced packaging. Another example is for AMS. We do a glass on die. There's a filter glass, which is then a special sewn and special made by us and put and glued on top of the die. And in the end, still encapsulated with an active area left free of molding component, which is the most important one. So that is still working for light sensors. Also for RF components, So Barry mentioned already that high frequency is very important, for us as well. So we integrate here several technologies. So there are several dies. First thing, capacitors inside, diodes inside, and one big ASIC, for example. On the right side, you can see two capacitors and the die in the middle. Then you can see we can integrate shielding. That means to avoid crosstalk between the different sections. So Eric mentioned that switching or partitioning is very important. Yes, that's right. Also for RF applications, so that you have, for example, the power amplifier is decoupled from the receiver part. This kind of things is done with shieldings. So we can integrate such kind of shieldings. And that's how we see the market. So we started with standard SOIC packages and then go to different packages like fluid sensor, radar sensor, or force sensors with different access to the medium which needs to be measured. For us, we are mainly in the advanced packaging for sensors. That means MEMS, but also you see on the bottom side the QFN part. So we started with a standard QFN, make a hole inside, put a glass on top of this die, make microstructures on top of the package, and even use this for microfluidic packages. So there's always several things in one package. And that's the art of functional packaging for us. So from outline sketch, you see here, that's our drawing where we start normally. And then we make a volume manufacturable solution. This is for us the most important thing, that it can be made directly in millions of parts. Because samples, we can run samples. We have a sample line, but this is then for Barry if he develops something or if Eric develops something, so they can come and we make the first samples out of this. And then if we go for a development, we go directly for volume manufacturing. So Eric is on the IMEC is more on the on the foundry side. Barry is more in between, and we are on the manufacturing side. I think this is the way we can cooperate also together on the Novio Tech campus. Thank you.
Okay, many thanks, Oliver. Very nice information about your activities, and cool to see that you have 47 people working here in Nijmegen in the industry. I think very important, and it reminds me of our first topic special, I must say. Like 2 months ago, the first one was about geopolitical changes and challenges. And I think it's very clear that what you and Eric, IMEC, and Barry do, that kind of institutes are very valuable towards us, the Dutch semiconductor industry. Important to keep this kind of high-tech knowledge and production within our premises, so that we are less dependent on other countries with their possible own priorities, which can be different, of course, from us. Well, looking at the time, we have about 20 minutes left for any questions or discussions between us. Is there anybody that'd like to take a kickoff and raise his digital hand, unmute the mic, and enter the room, so to say? Well, otherwise, for now, I have one question. It's for Barry. Barry, perhaps you can tell a little bit about your way of working compared to a more general market approach. Are there any differences?
Yeah, well, as was said by Oliver, of course, we are a non-for-profit research center. So we're not a university, so we don't do research just for research. We research and develop only if there's a need from market. But I think the main difference is that we don't see ourselves as a standard supplier, but that we do this together with our customers. And that's the only way to do it. I mean, it's not possible for us to have a customer say, okay, please design or develop this, and then let us know when you're finished. We really have to do this together. So I think that's the biggest difference between the way we operate And well, I don't even know if there are organizations that do exactly what we do in a commercial side, because this is very innovative and that's therefore also very risky business, of course. But I think that separates us from, well, the usual way of working, let's say. So.
Yeah. Okay. So with a real application focus, so to say. What you do?
Yeah, well, application demand focus. If that's what you mean with application, it's always the demand of the customers, the end customers that need to solve a specific issue, and that's where we focus on.
Yeah. Okay. Also, looking at new or other materials, Oliver also mentioned that they have quite some experience with new materials.
Is this a question, Tom?
Yeah. Exactly.
Well, what is the question?
Well, Oliver, he showed something that they work with new materials.
Yeah.
That's also something passing by on your desk, so to say.
Oh no, definitely. As I said, in advanced packaging, having let's say new materials with new characteristics. For example, at the 100 gigahertz plus domain, a lot of materials that are out there are not even tested or characterized in this high frequency domain. So one of the things we are working now is setting up a process of characterizing these materials in this high frequency domain. And this is something we do together with universities that already have, for example, these facilities. No.
Okay, clear. Thank you. Somebody else would like to know something more from Oliver or Eric?
Yeah, this is Sonia from Sensio.
Okay, welcome.
I have a question to Barry. Is regarding the materials. How is challenging the materials are you looking for? Regarding is only for making samples and prototypes, or is also for production?
Eventually, always production. We all the things we do are, let's say, with the horizon inside of doing production. We are not the ones doing production, but if we provide a solution to our customers that cannot be industrialized, it's not a solution. So always, I mean, I'm not saying that the first step we do is let's say, handing it over or making it ready for production. But of course, a solution can only be a solution if it can be produced in large volumes. So this means, with regards to, for example, materials as well, that we can only use materials that eventually can be produced in large volumes. Yeah.
Thank you.
Okay, thank you. Jeff, I saw you raise your hand. Mr. Jeff Hubers. Welcome. Your microphone is on mute.
Sorry, there you go. Sorry.
Well,
Tom. I have a question for Eric, really. If I look at the presentations, could you share from your perspective where you would see the synergy between the three of you with CITC or with Sensio? Because as I look at the resolutions that you are working on, the technology high end, where could you meet?
Well, yeah, maybe share one slide again to just focus on that. So if you think on many of these high-level systems, we may have this kind of module or assembled dies. So at the end of the day, you can see this as like a reconstructed chip, actually, and they also need to be packaged in a specific way. And this optical module, I think there were some examples given by Barry on connection with photonics to chips. In our module, we have activities on photonics as well, and IMIC in a sister program. So the photonics module may be a module by itself, and how do you connect these things together? We do, for instance, one thing in particular, like these bridges here, these are silicon bridges. They are brought together with the other parts using wafer level molding techniques, which is a kind of a technology that is then closer to some of the industrial techniques used today. It's a bit different because we work on mainly on wafer level reconstruction. But at the end of the day, you need to go from this level of reconstruct the chip still to the package and housing. There may still be a lead frame somewhere or a package substrate. This thing is not standing by itself. And also, like I didn't discuss on that topic, but like if you think about the heat removal aspects or power supply, in some of these modules they talk about power densities going to the 10 watt per square millimeter, meaning thousands of watts for one module. Working at 0.7 volt means several thousand amperes going into the package. I mean, we could say it's not power electronics, but it's not so far away from it in the end, at the end of the day. So there may well be, I think, typical techniques that are used today for power electronics that also come into this structure, and that knowledge is important. And the cooling, so integrating cooling in the package, I think this is also for Sensio often an important task for how do you do that.
Okay, so really nice defined challenges for CITC and in the end maybe for Sensio, right?
Yeah, and of course not everything is a high performance computing module. As other things are also in sensors, they may be even more diverse. If you go to certain specific application domains, things can become quite complex these days. And that's probably an important trend towards the future, that you merge these sensing capabilities with increasing amounts of digital computing, machine learning systems, wireless communication. So you kind of make your cell phone or your smartwatch, at least, type of structure into many systems. I think if you are familiar with like smartwatch assembly packages, I would say, that are made for like the Apple Watch or for the earpiece. Actually, there the whole system is a package, but it consists of many different technologies combined together. I think that is very likely to be a direction for many application fields towards the future.
Okay, thank you.
Thank you, Jeff. Thank you, Eric. Somebody with a burning question or remark for one of us? Well, I have one for Oliver. Of course, you cannot share all of your strategy plans for your company. I fully understand. You can't, don't do it. Are there any next steps that you would like to embed in your company activities? Any ideas?
Oh, first, yeah, I think that it's for sure depending on the market, and for sure we want to grow. That's the first thing. So, and if you look to technologies, yes, for sure, we're looking into, say, newer technologies, especially also where Barry is working on. He mentioned the silver sintering, for example, such kind of things. We are still looking into it. Depends a bit on the application. For high frequency, high power, for example, such kind of die-attached materials is very interesting. So for sure, we look into such kind of things also in the research. What is Barry working on? So this is for sure clear. And but it is the question: when does the technology is such far that we can develop a process which makes it available for us to make millions? That's for us still the aim. So this takes time, and therefore we need a lot of process engineers for sure to develop such kind of processes so that it can be built in volume production.
Yeah,
for sure we want to grow, and we think RF is a very important market. However, still all the sensor market is for us still very interesting, because you always need access to out of the package to the medium you want to measure. So it doesn't matter if it is light or is it humidity or is it temperature. You always need an access to the outside, and this needs always to make an open cavity or a glass or such things on the plastics. And this makes the development nice, because there are so many aspects to develop, and also then with the CITC or with other institutes together to focus on these kind of aspects. So for sure, we want to develop all our technologies which we have at the moment in-house, for sure.
Yeah, okay, clear. But you need to wait sometimes for technology to land first, so that it is ready to make thousands or millions of.
Exactly. Yeah.
Okay. Is there any technology which looks very promising to you? Any specific one?
For me, what I think it's one very promising, but it's still on low level, but it's clad welding. So it's still, in my eyes, clad welding is nanowiring. This is a very important technology which will come for sure in the next 2-3 years into more markets, because it offers the possibility to die attach without gluing, so without epoxy in between. This means it's just a real metal connection between the die and the lead frame, or between dies, different dies. So which offers a very good heat dissipation to the outside world, and also very good electrical connections. So it's not only heat dissipation, warmth getting away from the dies, but also the electrical connection is very good. So I think this is a very good technology for power packages, but also for very hot packages. So especially what IMEC is developing, because these amps you get into the chip, they produce warmth, and this warmth you have to get rid of. So this is, and therefore such kind of technologies are very interesting also then, just to get rid of the heat.
Yeah, heat dissipation is important.
Exactly.
Yeah. Okay. Maybe a topic for a next a next special. Thanks, Oliver. Thank you.
You're welcome.
No, surprisingly, this clad welding was on National Geographic months ago. So it was the first time. It was the first time that I saw something completely, innovative, new on National Geographic before I heard it in this industry. Yeah.
Oh, I didn't see this, but I know that clad welding since I think 3 years now. We are working with a company in Germany with this since roughly 3 years. Yes.
Exactly, that company was on National Geographic.
Okay.
By the way, also good. Tesla. So you could also see how you assemble a Tesla. So it's quite interesting what you can see just on networks.
Interesting. Yes.
Okay. Thanks, Tony. A nice tip to watch back. Cool. Somebody from the public with a question or a remark or anything else? Oh, somebody just asked. At the end, we will share the presentations with all of you, so you can always look back. And the whole hour will be recorded, so you can also look into it, into the questions and the answers given by Barry, Oliver, and Eric. Well, I have. Sorry.
I think there is a question.
Yes.
There's a hand raised.
Yes. Hello. I have a question regarding the 3D chip integration. Do you think that there will be at some moment standard chips suitable for 3D integration, like FPGA or memory, which you can add to a custom designed chip?
Well, that is actually the point today on the chiplets, and you could say that the high bandwidth memory modules, HBM, are an example of that. Of course, you have to know that the HBM is actually, today, it's one semiconductor digital chip with up to 12 DRAM chips on top of that as one module that is used typically in high performance modules. And it has a standardized interface. And what people are trying to do with the chiplets is also something similar, that you can actually have an interface that interfaces two chips, and you can have multiple sources and reuse across that interface. There is some interesting open standards that are being developed for that. There is a AIB standard from the CHIPS consortium, and there is the BOW, bunch of wire standard from the Open Compute platform. And these are open platforms. There are others that are more proprietary, also from Intel, from AMD, TSMC, and so on. But there are some open standards that are being pushed as well. And that may be more successful in the end, because HBM was also a standard proposed by JEDEC, kind of open, semi-open, let's say, whereas some other memory companies choose to go with private solutions. And at the end of the day, the open solution won out because it allowed system companies to choose between memory suppliers, for instance, to optimize their system. It's an important evolution as well.
Yes, I think open standards help a lot to bring the market forward.
Yes.
Okay, thank you.
Thank you, Maurice. Thank you, Eric. Well, looking at the clock, the hour is almost passed. Goes quite quickly, I must say. If there are no more questions, or maybe Oliver or Barry wants to add some final words to today's topic special, you're free, of course.
Yeah. No. Well, first of all, thank you for giving us the opportunity to speak. I think that we're all aware that the relevance of this topic. Of course, let's say the networking part of these online events is always a bit more difficult. So I hope that we can continue with this topic once we can do this offline again.
I hope, and then we have a borrow with a beer with it, and then it's got better.
That's exactly what I mean, Oliver.
Yeah,
you can mention it.
No, you're right, Barry. Let's hope we can be all together in one big room very soon, with some bites and some drinks, of course. You're more than welcome to come over. The next topic special is already scheduled, I must say. It's for September 21. So we still have some time to arrange things and to get back to a normal situation, so to say, in the country, in the world. I have a question to all of you. This is a platform by us and for all of us. So if somebody has a certain topic, a suggestion, you're more than welcome to mention it now. Drop us an email, give us a call. We have some ideas for new topics, so we will also fill the agenda, but please help us, so to say. If there's something you would like to know more about, or to host, to present, of course, you're also welcome to join as a presenter. Well, if there are no more questions left, I really like to thank Eric for your great presentation and all the in-depth information. Cool to see what you are doing on your side with an EMAC. One of the first major issues you mentioned was cleaning surfaces, but of course also the increasing complexity. So yeah, getting more and more costs. So I think that's one of the biggest drivers for advanced packaging to save money, to be cost efficient. And of course that's important in the whole world. Same for you, Barry. Thank you very much for your time and your information about CITC, and of course Oliver, last but not least.
Thank you.
Yes, thank you.
Cool to see, and I'd like to thank all the others, of course, for joining and your questions and your time and attention. I think today or maybe tomorrow we will send around all presentations and a link where you can look back at the final hour, at the last hour we've been together. So for now, thanks again. I hope to see you soon, and feel free to drop any questions or topics for the next one.
Thank you.
Bye-bye.
Bye-bye.
Okay.
Bye.
Bye.
Thank you. Have a nice evening. Bye-bye.